Hey pre-calculus friends, here we are in section 1-2. We're going to be talking about composition of functions. So looking at our vocabulary today, we don't have quite as extensive vocabulary as our last section, but this is going to take us some time. We're going to do our very best and we're going to do what we can. Okay, so operations with functions. You remember functions, right? We talked about them last time, and particularly function notation means we've got like an f of x, a g of x, and it's some kind of equation. G of x is equal to x squared plus 5, and maybe f of x is equal to 7x to the third power, something like that. So we can do operations on functions, and you know what operations are, meaning we can add them, we can subtract them, we can multiply them, we can divide them, and so that's what this language here is. But then we have another thing we're going to talk about, which is the composition of them. So in a way, it's like a new operation in a sense. So the sum of f of x and g of x as we have it here would be simply adding those two functions together, and so we would get 7x cubed plus x squared plus 5, recognizing that f of x, I'm going to highlight in purple here, is defined as 7x cubed, and g of x, which I'll write in highlight in red rather, is going to be defined as x squared plus 5. So we're literally putting those two guys together to come up with, I don't know, a monster function, another function, and that's what we have here. That's simply finding the sum of functions. Pretty straightforward, pretty simple. The difference of functions is also going to be similarly focused and easy and all that stuff. So g of x minus f of x would end up being x squared plus 5 minus 7x cubed. And that's it. And again, the difference is literally what you think, the subtraction of two functions. Product, you got it, would be the multiplying of two functions. So g of x dot multiplication sign f of x. So what that would look like is we would take our g of x, which is x squared plus 5, and multiply it by 7x cubed. And I'm going to put it like this because we know multiplication is commutative, so it doesn't matter which one you put first. And so this would require me to do a little distributive property. And then so the product of those two functions, is going to be 7x to the 5th power plus 35x cubed. All right, pretty good. Quotient. Quotient is division, if you forgot that. So quotient is the answer you get when you divide. Therefore, when I'm dividing these two functions, I'll get two different answers depending on which one I use as my divisor and which one I use as my dividend, or I'm going to actually call it numerator and denominator because of the way we look at it. So f of x over g of x, or taking g of x and dividing it by f of x. Both of these are definitely ways that you will see functions used, and you know what to do. We would simply replace f of x with 7x cubed and replace g of x with x squared plus 5, and vice versa as we're looking at it over here. I know this isn't looking neat, but I'm hoping you guys are getting it. All right, so that's what happens when we're looking for the quotient. And finally, composition, and iterate. Iterate is kind of like a composite. We'll talk about that maybe a little bit closer to we'll talk about that. So what does composite function mean? So we've got these two functions, which are cute, and we've added them, subtracted them, multiplied them, and divided them. Now when we compose them, we do something like this. The notation for composition is f circle g of x, or we can compose them the other way, g circle f of x. I don't want you to get that confused with multiplication. Sometimes I call it fog and golf to really emphasize that it looks like an O there. And what they mean is it means you take the function f and evaluate it with g of x. And you take the function g and you evaluate it with f of x. Now, what in the world is she talking about? What does that mean? You remember how I said when you have to figure out a function and you're substituting in there, it might make sense. So I'm going to change the function f, which we have defined up here. I'm going to write it as f of blank is equal to 7 times blank cubed. Well, this is a perfect opportunity to utilize that. What I'm going to do is plug in the value of g of x. And now what I'm getting is the composite function f of g of x. That's how I'd say it, f of g of x. We don't actually say fog, I just say that in my mind. So f of g of x. What is g of x? Well, remember, g of x is x to the second power plus 5. And so wherever that is in my x value for my f function, I'm going to plug in x squared plus 5. And then so what I would do is multiply all of this, x squared plus 5, by itself 3 times. That means take it to the third power and multiply by 7. That's going to give me an ungodly, really large number that I don't feel like is necessary for our example, but I just want you to understand what's going on there. Now, the thing is, we need to realize that composition of functions is not commutative. It does matter the order. So if I were to do it in the other direction, g of f of x, right? I'm going to do g of blank is equal to blank squared. Remember, I'm thinking about this right now, plus 5. And I'm going to replace that blank with the function f of x. What is f of x? Well, f of x is 7x to the third power. So I'm substituting that in, and you can see right now that we're getting a very different answer, right? I'm going to end up here with 49, because I can do this one easily. 49 times x to the sixth power, x to the third to the second is therefore the 6, and then 7 to the second power is 49. You got that. Plus 5. I end up with a relatively simple binomial. Here, I'm going to end up with something that's not quite a binomial at all. It's going to be pretty big. So I'm hoping that makes sense. Let's get started with some examples. So literally our example looks a lot like not examples, but the vocabulary that we just played around with. So here we're finding the sum of two functions, the difference of two functions, the quotient of two functions, and the product. So you guys should be well equipped to do this on your own. I think sometimes when you're doing videos, and I know you're taking notes because that's a mad important part of mathematics. You just got to take notes. But as you're taking notes, I would just suggest you try it before me. Pause me and then see what happens. All right, so pause me. See if you can do these on your own. So during our pause, I wanted to make things a little bit more colorful and so you can see exactly what's going on. Please, I hope I'm not overdoing it and you're not shocked. But what this is going to be, the sum, we'd end up writing as 3x squared, right, plus 4x. And then I'm going to have plus 1. And notice I joined these guys together. These guys are not common factors. And so this is what we have when we bring those two functions together by addition. By subtraction, we're going to have 3x squared. And by the way, observe my parentheses. This parentheses needs to be there. I don't want you just subtracting the 4x and then adding the 5. The whole thing has to be subtracted. So this is 3x squared minus 4x. And now this is actually a negative 5, so this is going to be a minus 9, and that's going to be that answer. Over here, multiplication is going to require us to FOIL. I wonder if you remember that, or to, sometimes I call it the extended distributive property. I'm going to multiply 3x squared times everything here, negative 4 times everything there, and so I get 12x to the third power plus 15x squared minus 16x and minus 20. Since there's no common terms or no like terms, I'm going to just leave that there, and that's what that is multiplied out. And I can do some kinds of division, but this is going to be fine for us. We're going to leave it as this fraction. And so this is what we should get, or this rational function. And this is what we should get when we apply those operations on these functions. Example 2 is going to require us to look at some information that we got in the beginning of the chapter. That's why it's included here. Each year, thousands of people visit Yellowstone National Park in Wyoming. Audio tapes for visitors include interviews with early settlers and information about the geology, wildlife, and activities of the park. The revenue from the sale of X tapes is given as R of X is equal to 9.5. And suppose that the function for the cost of manufacturing the X tapes is going to be given as C of X is equal to 0.8x plus 1,940. What function could be used to find the profit of the tapes? Well, a couple things we need to know. Profit is figured out. Revenue is all the money that comes in from a sales, right? And cost is how much it costs you to actually create the thing. And so when you think about profit, profit has to be the revenue, right, minus the cost. Revenue minus cost is going to give us the profit. So if we're going to write a profit function, we need the revenue function, subtract the cost function, and then the resulting function is going to give me the profit function based on the number of tapes sold. So as we can see here, what I did is I put the revenue function here, and then I put the cost function right here to represent what the function of the profit is going to be based on x. And I probably should have put the p of x in the front just to make it look more normal, but I just wanted to measure or follow the form that we have here. So I'm subtracting the cost from the revenue in order to get the profit. So that's part one. The next thing they want us to do is find the profit on 500, 1,000, and 5,000 tapes. And so of course we can put in each of these numbers to calculate that, but this might be a really nice time to introduce us to Desmos and how we can use some technology to help us out. So to access this wonderful calculator, what we're going to do is just go into our menu bar, not menu bar, but the address bar. We're just going to type in Desmos, and you'll see some cool stuff happening, and we can click on the graphing calculator or that, whatever. It's fun. Have fun with it. Check it out. But we click on graphing calculator, and then we get this really cool calculator that will graph everything we put in here. So what I'm going to do is actually input the p of x function that we had. Remember, it was p of x is equal to, let's see what was it? Hold on. So I come back here and I see, oh, the profit p of x is equal to one function minus the other. And I realized I actually, while we were talking before, I didn't have the 0 there, so I messed it up. I think I did 194 and not 1,940, so my bad about that. But now that I've caught my mistake, I'm going to now go over to Desmos. I made sure and put that in there, and voila. This is cool, I guess, right? But what's cool about this is that now that I put this function in and I need to evaluate the function at a couple of places, remember those places? We need to figure out what the profit is at 500, 1,000, and 5,000. I can do that really easily. I know you guys can calculate it, but why waste the time? Right now would be a great time to use Desmos, so I'm going to go back and I'm going to put capital P, open parentheses. The first value was 500, and I see what that is. Then the next one I can figure out is capital, and it's calculating it for us. It is recognizing the P function, and it is plugging in that information, and I am saving lots of time because I'm not multiplying it, and I'm also not pulling out a calculator saying, wait a minute, 9.5 times this number is, you know what I'm saying? So utilize the opportunities when you can. Lowercase p, it wasn't happy with it. It was like, I don't recognize you. Capital P, there it is. So there's our three answers: $2,410, $6,760, and finally, if you sell 5,000 of those thingies, you get $41,560 as profit. And so we write those answers like this. So in example 3, we're getting to the composition of functions. This is where I called it fog and golf, so you can remember that it's not actually multiplication, though it kind of looks like it. And so we recall that this means f of g of x, and this means g of f of x. And so you can see which one's on the outside and which one's on the inside per se. All right, so now that we have that, we're asked to evaluate those two things given the values of these functions, and we're going to do just that. So since we're going to do this one first, just because I have it written here, and f is the outside function, it's what I'm actually plugging g into, I'm going to write f of blank is equal to 2 times blank squared minus 3 times blank plus 8. And I'm going to do this by plugging in the value of g of x, and g of x is 5x minus 6, and so I'll plug that in everywhere around here. And now it just requires me to simplify this, so I'm going to square this term first, multiply by 2, distributive property with the -3, join like terms. So what we get after composing these two functions, I'm going to highlight this in this green color, is this situation. All right, we end up with the composition of the two functions equaling what we see down here below, 50x squared minus 135x plus 98. We're going to do it the other way, and do not expect to get the same answer. That happens rarely. That's actually a special situation. So we're going to do the same thing. We're going to write g of blank is equal to 5 times blank minus 6. And I need a little bit more space for my blank because what I'm putting in here is a lot of stuff. So I've replaced the x from the g equation with f of x, the value of f of x, and now I'm going to calculate as I did before. After using the distributive property, I'm going to join like terms together. And after simplifying, we end up with 10x squared minus 15x plus 34. Very different from this one here. So I know I don't want too many videos, but I do have to make a part 2 to finish this lesson. Be patient. We'll be done very soon. I'll see you guys soon. Bye-bye.